Okay, here's a problem that came across my desk. Let's do some more factoring of perfect square trinomials, but this time where the middle term is negative. Now, our first and last terms pretty much have to be positive because a perfect square is going to be positive. There are some exceptions to that, but we won't go into that right now. So let's just talk about what we do here. Is the first term a perfect square? Yes. What's its root? X. Is the last term a perfect square? Yes. What's its root? 4. Now, what is the product of the first and last two terms? 4x. What is double that product? Well, this one's negative 8x, so this has to be negative 4x, and this has to be a negative 4. And then that's all there is to it. So I get x minus 4 times x minus 4, right? There's my x and there's my minus 4. Or, of course, we could call that x minus 4, the quantity squared. And that's what makes it a perfect square. Anything squared is a perfect square. X squared is a perfect square, for example. Okay, let's take a look at another one. How about x squared minus 10x plus 25? Now let's look at this in another direction, possibly. What if well, no, let's just stick to the normal direction. But I'm noticing here that this is negative 10x. So I know that if I get half of that, I want it to be negative 5x. So I'm looking toward that. So the root of x squared is x, and the root of 25 is 5. And I'm going to make that a negative 5, so that when I multiply the roots of the first and last two terms, I get that negative 5x that I want. Okay, so again, it's a perfect square trinomial because the first term's a perfect square, the last term's a perfect square, and the middle term is double the product of the roots of the first and last two terms. And so that factors into x minus 5 times x minus 5, which we could write in condensed form as x minus 5, the quantity squared. Now it's important to understand the internal bits that are happening here, the work that I'm showing. A lot of you could just look at this and do it in your heads, and that's great. But this work is going to come up again when we use a method for solving quadratic equations called completing the square, which is also the basis for the quadratic formula. So stay tuned for that. This will come in handy again. If you have a math problem that you would like me to demonstrate, put it in the comments and I will. Hope that helps.